Let's take a look at our describing matter and energy skill builder. All right, so our first question, we want to be able to classify matter. So I have four substances here. We need to figure out if they're a homogeneous mixture, a heterogeneous mixture, a compound, or an element. All right, so let's see here. So our first one, our root beer float. So think about what a root beer float looks like. Is it all uniform? No, this is a heterogeneous mixture. All right, what about water? So water is H2O. All right, so is that more than one element? Yeah, this is a compound. All right, what about magnesium? So if I just have a piece of magnesium metal, that's going to be an element. Okay, and then what about if you have some tea and then you dissolve some sugar in it? When you look at it, can you tell the water apart from the tea, apart from the sugar? Or does it all look like one uniform mixture? It should look like one uniform mixture, so this should be homogeneous. Okay, all right. Now, one of the things that we have to do in science is be able to classify our matter as a solid, a liquid, or a gas. And each one of these three phases of matter does have a very distinct set of properties to it, right? So I've got some molecules that are far apart from each other and they're going to fill the available space. So is that a solid, a liquid, or a gas? It is a gas. All right, so gases expand to fill their container. They fill all available space that is there. Okay, now let's say I have something that's tightly packed. It has both definite volume and definite shape. So like my Apple Pencil. Doesn't matter what container I put it in, right? It's always going to have the same volume. It's always going to have the same shape. This is a solid. All right, but what about something that has a definite volume but not a definite shape? So the volume stays the same, but if I pour it from one container to the next, it's going to take on the shape of that container. That's going to be a liquid. All right, now what about particles moving around very quickly? So they're all bouncing around, moving everywhere. What is that? That is a gas. And particles aren't moving. They're just all stuck together. That's going to be a solid. And then if particles were moving slowly relative to each other, that would be a liquid. Okay. All right, now let's try physical and chemical properties. Okay. So physical properties, we don't have to change anything about the substance. All right. It's still going to be the substance. So salt melting, is that physical or chemical? That's physical. All right. Because my salt's still salt. It's still sodium chloride. All right, poisonous. Mercury is poisonous. Do you think that's physical or chemical? Well, think about what poisonous means. If I ingest something poisonous, is it going to create a reaction inside of my body? Yes, which means it's a chemical property. Okay, salt is granular and white. Have I had to do anything to the salt, or am I just observing it as is? Okay, physical. All right, you drop Alka-Seltzer tablets. They form bubbles in water. What do you think that is? Chemical. Okay, water is going to produce a gas with calcium metal. Chemical. And then water appears colorless and odorless at 20 degrees Celsius. That should be physical. Okay. All right, now this next one, I made you think about a whole paragraph and underline. All right, so we're going to underline our physical properties. I'm going to do it in red because that's the first color I tapped on. When you turn it in, I don't care what color you use as long as you let me know what color you used. Okay. All right, so I've got sample of calcium. It says it's electrically conducting. Okay, that's physical. It says it's white. Oh, that's also physical. Metal. All right, that's physical. Shiny. Physical. relatively soft, melts at 850 degrees. Oh, and boils at 1440. All right, that's all physical. All right, that's just, properties of that particular substance. All right, we're going to put it in some liquid water that was at 25 degrees Celsius. Oh, well, that tells us something about the water. Is liquid the description of the state of matter? Yeah, that's physical. Okay, and the temperature the water's at, is that physical or chemical? That is also physical. All right, so those are all physical properties. Now it goes on to say that the calcium reacted slowly with the water to give bubbles of gaseous hydrogen and a solution of calcium hydroxide. All right, so we're going to do chemical in blue. All right, so the key word here is the calcium reacted, right? So something's happening. And we got bubbles of gaseous hydrogen. We didn't start off with hydrogen, so those bubbles of gaseous hydrogen, that has to do with a chemical property, right? And a solution of calcium hydroxide. All right, so a reaction had to occur for that to happen. So that's chemical. All right, also on chemical and physical, now we just want to decide if these are chemical or physical changes. So if I pour baking soda and vinegar together and I get fizzy bubbles, is a reaction occurring? Have I changed my original substances? Yes. So this is chemical. All right, I'm going to take a mortar and pestle and I'm going to grind down some aspirin. It's going to go from a tablet to tiny little pieces into a powder. All right. In my grinding, have I changed the aspirin? Or have I just changed the aspirin from a big piece of everything smushed together to a bunch of tiny pieces? Yeah, just a bunch of tiny pieces. So this is physical. Okay, forging iron. So to forge iron, I'm going to heat the iron up really, really hot. I'm going to pound on it with a hammer. And then I'm going to stick it in some water to cool it down. Then I'm going to heat it up again. I'm going to pound on it with a hammer. All right, have I done anything to the iron other than heating it up and shaping it to something different? No, so this is physical. Okay, fruit ripening. So if you think about a banana starts off yellow, and if you let it sit out, or actually it can start off green, depending on how you buy it, and then it goes yellow, and then it goes brown, and it goes even more brown, and it just kind of gets gross. Is that a physical process or a chemical process? When I have that brown banana, can I turn it back into the green banana? No, this is physical, or this is chemical. Okay, now some chemical processes are reversible. So that does happen. And if you take a bunch of chemistry, you will learn about reversible processes. So there are things that are chemical in nature that are reversible, but the end result is always you form new substances. Okay? All right, burning wood. So if you think about wood, as you burn it, you have smoke and ash. And when you're all done, do you still have a log of wood? No. So what do you think? Chemical. What's interesting is early people, when they were trying to explain this, phenomenon of you light the wood on fire and all of a sudden things burn away, they didn't really understand that new substances were being created. Right? They didn't understand chemistry. And so they didn't know that as the burning was happening, that all that ashy stuff was a chemical reaction as the wood was burning. And so they were trying to explain where, you went from this big old hunk of wood to just a few little pieces of ash when all was said and done. So they invented a substance called phlogiston. And so to them, everything had phlogiston in it, which was this like empty stuff that burned away. But we know now that a chemical process occurred and new substances were created. All right, dissolving salt in water. So if I dissolve salt in water and then I go boil off the water, do you know what happens? The salt is left behind. This is physical. Okay, dissolving something is just a physical process. So like if let's say you're gonna make pasta and you put your pot on the stove and you put some water or some salt in it and you turn it on to boil. And then you're like my husband and you forget that you set a pot of water to boil. And you come back and all the water is boiled away and now you've got this white chalky stuff. That's the salt that's left behind. Okay? In fact, if you do that with tap water, you're always going to have some chalky white stuff behind because our tap water has a whole bunch of dissolved stuff in it. All right, alcohol burning. What do you think that one is? That one is chemical. All right, and our last question. We are thinking about kinetic or potential energy. So kinetic energy is energy of motion. Potential energy is energy that could happen. All right, so I've got a ball at the top of a hill. It has not rolled down yet, right? So it's about to start rolling, but it's up here at the top of the hill, ready to roll. So it's not in motion. So it's potential energy. Okay. Okay. All right, now we're riding a bike. All right, so if we're riding a bike, are we in motion? Yes, so that's going to be kinetic energy. All right, now your car, if you have one, it's in a parking spot, it's in your driveway, it's in your garage, it's somewhere. It is not moving right now. At least I hope it's not because you're watching a video. So that gas that's in your car, is it potential energy or kinetic energy right now? It's potential energy because it's not burning yet. It's not creating, any energy that fuels your car. All right, so that is our first skill builder. All right, and so this is the way it'll work. I will post the skill builders at the beginning of the week. You'll have a few days to work on them, and then I will post answers closer toward the time they're due, so that way you can go through and check your answers to see how you did before you turn it in. But definitely try it first. All right, if all you ever do is just copy down what I write, it's not going to help you. So make sure you're trying them before you watch the video. All right, so hope you all did well on this and you understood it before watching this video.